Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 2-6, Solving Compound Inequalities. So compound inequalities are two inequalities joined by an and, which is like an upside down U, or an or, which looks like a U, to solve a compound inequality. 1. Solve each inequality independently, separately. 2. Graph the solutions above the same number line. 3. Decide which parts of the graph represent the solution. If and is used, it's the common points, the points in between. And is in between. And or is used, it's all points, okay? Then the graph the solution on the number line. So and is the in between. So like right here, and is your overlap, where your ors go in opposite directions, okay? So, write and solve in set notation. Graph the solution. 2x is less than 8 and 3x plus 2 is greater than -4. So, when you divide by 2 on both sides, you get x is less than 4. When you subtract 2 from both sides, you get 3x is greater than -6. Divide by 3 on both sides, x is greater than -2. So I go over to the 4, I do an open dot on the 4, shaded to the left, over to the 4, open dot, shaded to the left. I go to the -2, open dot on -2, shaded to the right, and I can see that the overlap is in between, and it has to satisfy both. So our solution set, x such that x is less than 4, and x such that x is, they messed up. They should have had that as greater than -2. That's a typo, greater than -2. Okay? Or you can write it together. You can write it as x such that it's between -2 and 4. So -2 is less than x, which is less than 4. So when you had the -2 in the x, the alligator was eating the x. It's still eating the x. When you had the x and the 4, the alligator was eating the 4, it's still eating the 4. Make sense? So on our next one, we have x is greater than or equal to -1, greater than or equal to -1, or x is less than or equal to 2. So we have this one shaded this way, right? X is less than or equal to 2. So this one's shaded this way, and that one's shaded that way. Okay. So we have x such that x is greater than or equal to -1, or x such that x is less than or equal to 2, or the set of all real numbers. Because if you're shading this one this way and you're shading this one this way, and either one will satisfy it, either or, right? It doesn't have to satisfy both. With and, it has to satisfy both. With or, it doesn't. So this is going to just essentially be all real numbers. Any number you come up with is going to work. So we have x is greater than 3. So we have an open dot on 3, and it's numbers that are greater than that, right? And x is less than or equal to -3. So this one goes this way. This one goes that way. Where do they overlap for the and? Do they ever overlap? No. So this one's never going to work. So it's just an empty graph. It's never going to work. It's an empty set or no solution. Because x is greater than 3 and x is less than or equal to -3, that never happens. It's never greater than 3 and less than or equal to -3. It can't be both of those. Okay, so x is greater than 1. So let's just kind of do this above like they suggested so that we don't screw it up again on the graph. and then x is greater than or equal to 3. But this one is an or, right? So essentially when you combine those, it really just looks like this, right? Open, going this way. So x is greater than 1, and, or x such that x is greater than or equal to 3. So when you combine those, it's really just x is greater than 1. So with or, you combine them. With and, it's only their overlap, only what they have in common. In part C, why is the solution set the empty set? Because it's an and with nothing overlapping, nothing in common. You only graph the overlap. In part D, why is the solution set x such that x is greater than 1? Because when you combine them, all solutions end up being greater than or equal to 1. Make sense? Write the solution in set notation. Graph the solution. 4x plus 2 is greater than 14. So subtract 2 from both sides. And subtract 6 from both sides. And is union. No. Or is union, right? And is intersect. And is intersect, or is union. Intersect. Have you guys ever heard of intersect and union? So they intersect. The n, sorry. So divide by 4. X is greater than 3, and x is less than or equal to negative 2. So our solution set, x such that x is greater than 3, and x such that x is less than or equal to negative 2. Okay. And then graph it. So open out on 3, going this way. Closed out on negative 2, going this way. What do they have in common? What do they have in common? Nothing. So it's actually empty set. There's no solution. So nothing gets graphed. Right? There's nothing that you can graph with them together. Number 2. Divide by negative 3. X, flip my sign, negative 1. Or union minus 3 minus 3. 2x is greater than or equal to 11, 10, 9, 8. Divide by 2, divide by 2. X greater than or equal to 4. So we're going to have x such that x is greater than negative 1, union x such that x is greater than or equal to 4. -1 this way, +4 this way. So when I combine them together, open dot on -1, going this way because it's or. So my solution can simply just be x such that x is greater than -1. Right? When you combine them, you can just leave it at that. -2 minus 2, x is less than -1, or -1 minus 1, -5x is less than 15, divided by -5, x is less than -1, or x is greater than -3. So solution set, x such that x is less than -1, or solution set, x such that x is greater than -3. Guys, we have 3 minutes. All right, so now we're going to graph this. Do not pack up. We have 3 minutes. Open dot going this way. Open dot on -3 going this way. And this is an or, so it includes both. So basically when we combine this, well, those open dots get filled by here and here, so it really just includes everything, right? So we're actually going to get all real numbers, right? When we combine it, it's actually all real numbers. Your solution set's going to be all real numbers. And then we have one more question. +3, 4x is greater than 4. Divide by 4, divide by 4. You guys better have these notes tomorrow. X is greater than -1. Add 2 to both sides. 3x is greater than or equal to 9. So we shouldn't be packing up before class is over. X is greater than or equal to 3. So our solution set, x such that x is greater than -1. And x such that x is greater than or equal to 3. So we're going to have a -1 going this way. We're going to have a +3 included going this way. Is there any overlap? Well, yes, there is. They overlap from here all the way on. So our other solution, right, we could also just write it as x such that x is greater than or equal to 3 because that part is overlapping. Okay? And that is everything on today's lesson on 2/6, solving compound inequalities. Your homework is going to be page 101 and 102. Have a great night. Like and subscribe.